Yo, welcome back, everybody. Hope you had a great spring break. Hope you're geared up for the fourth quarter. We're gonna get this thing started. We only have 42 more days of school, and you guys are headed off to the high school. I hope you're ready for that. Kind of the roadmap for us. We are gonna want to get through unit. I don't remember what unit we're on. Seven. We're gonna get through unit 7. Which is about right triangles in particular. And then that should be pretty good for us. I think that you'll be decently ready for the state test. So we're going to get through Unit 7. We're going to start reviewing for the air test. We're going to take the air test at the end of April. And we're just going to finish up with Unit 8. And that's going to be kind of our roadmap out of here. So we got 1 unit in April, take a test. Review there, 1 unit in May, take a test, we're done. So that's pretty cool. Obviously, the last test you guys took is going to be on this fourth quarter too. So you are going to have 3 tests on this quarter. And yeah, that's kind of cool to be able to talk about the end of the year stuff, right? So, what are we talking about today? We're going to just start with triangles. So in particular, we are going to want to focus on some specialized triangles in this unit, but I think it's just good to kind of talk about the things that we know about triangles and go from there. So there's already a couple things that we've talked about, right? We know that all triangles have 180 degrees. And what's cool about that you guys haven't talked about is that's actually the basis for where we get every single shape's degrees from, right? So if I said, hey, here's this pentagon, how many degrees are in this thing? Well, what I would do is I would sit here, grab a vertex, and connect it to all the other vertices, and tell you how many triangles it has. So a pentagon is made up of 3 triangles. So that means I'll just go 180 times 3. Bam, bada, bam. And I can tell you that all pentagons are going to have 540 degrees in them because they're made up of 3 triangles. And I would do that with every single polygon. In fact, there's a formula that is called n minus 2 times 180. That tells you the degrees of any polygon. And we get this because that's how many triangles are in a shape. Notice this has 5 sides. The n stands for number of sides. 5 minus 2 tells you that there's 3 triangles in it. And then 3 times 180 gives you the 540. So that's pretty cool. But we're going to still use that idea. That's never going to go away. That's a very important fact in geometry, is that triangles are going to be 180 degrees. A couple other things that are cool. We know that there are some types of triangles, right? So there's 2 criteria. We can have triangles that are based on their angle and triangles that are based on their side length. What?
I was just thinking about you spelling these.
Oh yeah, I got that. No problem. My wife thinks I can't spell anything. Well, she knows I can't spell anything actually, but we'll prove her wrong. So, the angle types, those are the, easy ones. We have the acute triangles. And I always ask this question and I say, what is an acute triangle? Like, what makes it acute? And people say, less than 90. But what's less than 90, right? All angles are less than 90. That's very significant. All angles are less than 90. So there's acute triangles. There's right triangles, which we're going to focus on the most, which means that there's one 90-degree angle. And then there's obtuse triangles that have one angle greater than 90 degrees. So again, not all the angles are greater than 90 because that would never add up to 180, right? You can't take three numbers bigger than 90 and add them and get 180. That doesn't work that way. I know that you guys know these, obviously. This is just easy peasy review. But acutes, all less than 90, writes 190, obtuse, one bigger than 90. The side length ones, hopefully you guys know these two. Oh boy, equilateral. I'm pretty sure that's weird. That's right. I think it has an I in there. I think that's right. Equilateral triangles say that all sides are congruent. Right? All of the sides are the same. So if I draw the triangle, that would be what we would call a regular triangle. Right? When we talk about regular polygons, that means all their side lengths are the same, all their angles measures are the same. An equilateral triangle is going to be one that all the sides are the same. If only two are the same, isosceles means that two sides are congruent. And I always think of an icicle, right? Two sides that are the same, and then this part's like shorter up here, whatever. It could look like anything, but two sides are the same. And then if none of the sides are the same, we call that a scalene. No sides congruent. Cool. So that's all stuff that you should know. Obviously, I was just kind of running through some quick hitters with you there. But we're going to focus obviously on right triangles. But all of those are important to know and be able to identify at any time. What else is important about triangles for us? Well, we're going to talk a little bit more specifically about right triangles tomorrow. But there is one more kind of nugget that I want to talk about. And that is, let's actually throw some numbers in here. So, let's just call this A, we'll call this B, we'll call this C. Okay? And I'm going to tell you that this up here is 80 degrees. I'm just going to try to keep this simple. 60 degrees. That's 140, so this would be 40 degrees. Okay. So, a couple other rules about triangles. When we talk about longest side or biggest angle, sides and angles are always related to the opposite side of them. And that might sound weird to you, but if you think about an angle, when I change how big this angle is, notice that my hands are not growing, right? Those sides aren't changing. The one that's not drawn in is the one that's changing. Right? That's the side that's going to get longer. And that's the one that's across from the angle that moves. So in particular here, I know that C is the longest side because it's across from the biggest angle. Does that make sense? So the biggest side is across from the biggest angle. I could also tell you that B over here is the shortest side because it is across from the smallest angle, right? So the sides and angles directly across from each other are the ones that are going to be related. I could do this the opposite way as well. I could say, hey, check out this triangle here that we will call, we won't call it anything. I guess we'll call it triangle ABC, like this. And if I told you that this side was 13 meters, this side was 10 meters, and this side was 11 meters, right? Who cares? I can tell you, I don't know how big these angles are. We can actually do that later, sort of, kind of, maybe. But what I can tell you is which angle would be the biggest angle, right? So 13 is the largest side, the longest side. that means that C has to be the biggest angle because it'd be across from the longest side. Likewise, over here, A would be the smallest angle because it's across from the smallest side. Right? So, angles and sides, if they are opposites, they're related to each other. And the last thing about triangles that you might not know about is not any three sides will make a triangle. I don't know if you know that or not, but let's say I said something like, if one side, can I make a triangle that's 2, 2, 5? Like 2 inches, 2 inches, and 5 inches. Could I put that together and make a triangle? Well, the answer is no. And I'll show you why. Let's say this was 5 inches. If I put 2 inches on this side and 2 inches on this side, these things are not going to touch each other. Actually, that looks like they still might, but they're not. They're not long enough. So in order to make a triangle, the two smaller sides, when you add them together, have to be greater than this other side. So 2 plus 2 equals 4, and 4 is not greater than 5. So therefore it does not make a triangle. And that's going to be true for any triangle. So if you take up the smaller two sides, you add them together, they have to be bigger than that third side. Otherwise, my sides won't actually connect. They won't be long enough. I used to do this cool thing with spaghetti, where we actually measured it and then put it together and saw that you actually cannot put them together. So while you guys are at home virtually learning, if you want to grab some spaghetti from the pantry and try to make some triangles, you can actually have some fun and see that it doesn't work out. All right, so yeah, just some basic knowledge about triangles. And tomorrow we'll dive a little bit deeper into right triangles. Cool. Later.